Attention! This channel provides original historical analysis based on sources and research. We do not simply recount events, we analyze their causes and consequences, explaining them through original narration, editing, and visual diagrams. A list of sources is included in the description. Enjoy watching. Welcome back. Today we are examining one of the most consequential and least discussed factors of the Second World War, the logistics system that sustained the Allied advance across Western Europe. This is not a story about individual heroism or battlefield tactics. It is a story about organization, industry, and the decisions made far behind the front lines that determined the war's outcome as surely as any battle. The facts speak for themselves. In December 1944, Field Marshal Gerd von Rundstedt sat at his headquarters in the West and delivered a confession that would have been unthinkable 4 years earlier. Germany was losing the war, he told his staff, and not because German soldiers lacked courage, and not because German generals lacked skill. 3 factors defeated us in the West, Rundstedt later explained to British military historian Basil Liddell Hart. First, the overwhelming superiority of Allied air power, which made all daytime movement impossible. Second, the chronic shortage of motor fuel, which left panzers and aircraft unable to operate. Third, the systematic destruction of every railway line, making it impossible to move a single train across the Rhine. It was a precise, professional assessment, and it pointed directly at the single factor that had decided the war in the West: logistics. Rundstedt's confession revealed something that German military planners had failed to understand from the very beginning. Allied air power had not merely won battles, it had systematically strangled the German supply network. But there was a second half to this story, one that Rundstedt himself did not fully appreciate even at the end. While Allied bombers were destroying German railways and fuel depots, American logistics officers were constructing a supply system of unprecedented scale, operating with an efficiency that no European military tradition had ever produced or anticipated. The misjudgment began years before the first American truck rolled onto French soil. Throughout the early 1940s, German military intelligence compiled detailed assessments of American industrial capacity and military character. The conclusions were consistent and, as events would prove, catastrophically wrong. America was described as a nation of businessmen and consumers, not warriors. Its military traditions were considered shallow compared to centuries of Prussian excellence. Its soldiers were assessed as soft, pampered by peacetime comfort. Its officers were rated as inexperienced, having never faced the tested crucible of European warfare. German generals had genuine reasons for confidence in their own abilities. The Wehrmacht had spent years perfecting the art of mobile warfare through rigorous doctrinal development and hard combat experience. German panzer divisions had conquered Poland in 5 weeks during September 1939. They had defeated France in just 6 weeks in May and June of 1940. They had driven deep into the Soviet Union during the summer of 1941, covering hundreds of kilometers in weeks. This was Blitzkrieg, lightning war, built on speed, concentrated force, and the aggressive exploitation of success. German officers were trained from the beginning of their careers to seize initiative, act independently, and accept nothing less than total victory at the decisive point. What German doctrine did not emphasize, what it actively discouraged as a career path, was the business of supply. Logistics was considered a secondary concern, something competent staff officers handled quietly in the background, while brilliant field commanders won glory and promotion at the front. The best German officers gravitated naturally toward combat commands. Logistics assignments attracted lower quality talent. This was not an accident. It was a deeply embedded cultural preference, rooted in the Prussian military tradition that prized operational art above all else. Clausewitz had written extensively about the genius of command, and almost nothing about the science of supply. The Americans approached war from an entirely different perspective. Their national tradition was not centuries of cavalry charges across European battlefields. It was transcontinental railroads spanning more than 3,000 miles. It was nationwide trucking networks delivering goods from the Atlantic coast to the Pacific. It was assembly line production that had fundamentally revolutionized manufacturing at every scale. It was the efficient movement of agricultural products and industrial materials across vast distances that made European geography look compact by comparison. When American military planners looked at the challenge of invading Europe, they did not see it primarily as a tactical problem to be solved through battlefield brilliance. They saw it as a logistics problem. How do you move millions of men and tens of millions of tons of supplies across an ocean? How do you land them on a hostile, fortified shore? How do you sustain them as they advance hundreds of miles into enemy territory against a determined and experienced opponent? These were engineering questions as much as military ones, and the answers required innovations that German planners never anticipated and could scarcely conceive of as possibilities. The contrast in perspective extended to every level of the two military systems. A German general looked at a map and calculated angles of attack, rates of advance, and the weight of forces at the point of contact. An American planner looked at the same map and calculated tons per day, road capacity, turnaround times, and fuel consumption rates per vehicle mile. Neither approach was wrong in isolation, but in a prolonged industrial war fought across a continent, one approach would prove decisively superior to the other. The transformation of American logistics capability began months before a single soldier set foot on French soil. In England, Lieutenant General John Clifford Hodges Lee commanded the organization officially designated as the Communications Zone, the vast rear area structure responsible for everything from artillery shells to field rations to medical supplies. Lee was a deeply controversial figure personally. His initials were JCH, and soldiers said they stood for Jesus Christ himself, a reference to both his monogram and his intense religiosity. Eisenhower called him a modern Cromwell, acknowledging that his unyielding methods might be essential in a domain where discipline and precision were not optional. Under Lee's demanding command, approximately 2.5 million tons of supplies were stockpiled across England before the invasion launched. Roughly 62.5 million square feet of storage space was created in warehouses, depots, and temporary facilities scattered across southern England. The Communications Zone organization grew to hundreds of thousands of personnel, an entire army behind the army, whose sole purpose was to ensure that the fighting men at the front never lacked for anything necessary to continue fighting. German intelligence observed this buildup but drew the wrong conclusions from it. They saw mass. They did not see system. The German military establishment had spent years building the Atlantic Wall fortifications on a fundamental strategic assumption that any Allied invasion of the European continent would require capturing a major port almost immediately to supply the landing forces. Every significant port from Norway to the border of Spain had been heavily fortified and garrisoned accordingly. The logic was sound, given everything German planners knew about the practical requirements of large-scale amphibious operations. What they never imagined, what apparently never entered their planning as a genuine possibility, was that the Allies would not attempt to capture a port at all. They would bring their own ports with them across the Channel, assembled from components manufactured in England and towed into position piece by piece. That decision, and the engineering achievement it represented, would determine the first phase of the campaign before a single tank crossed the French interior. The concept of bringing artificial harbors to an invasion coast was not entirely new in 1944. Winston Churchill had sketched the fundamental idea as far back as 1917, during the First World War, when similar problems of coastal supply had presented themselves. He returned to the concept formally in a memorandum dated May 30, 1942. "Piers for use on beaches," he wrote. "They must float up and down with the tide. The anchor problem must be mastered. Let me have the best solution worked out. Don't argue the matter. The difficulties will argue for themselves. That directive set in motion 2 years of secret engineering development that would produce the Mulberry Harbors, 2 complete artificial ports, each capable of handling the cargo volumes of a mid-sized peacetime commercial facility. What emerged from that development process was unprecedented in the history of warfare. Each Mulberry Harbor, when fully assembled off the Normandy coast, enclosed approximately 2 square miles of protected water, roughly equivalent to the area of Dover Harbor. Construction consumed the labor of 45,000 workers, organized into approximately 300 engineering companies. The structures required roughly 1.5 million tons of steel and concrete in total. 213 massive concrete caissons, called Phoenix units, formed the outer breakwaters. The largest of these structures weighed over 6,000 tons individually. Approximately 10 miles of floating roadways, called whales, connected each harbor to the shore, allowing trucks and vehicles to drive directly from ships to dry land. German air reconnaissance aircraft had actually detected these enormous concrete structures in British waters before the invasion launched. Pilots reported seeing massive formations of unidentified objects that defied easy classification. German intelligence analysts received these reports and studied the photographs. They could not determine what they were looking at because nothing like it had ever been built before. The failure was not one of intelligence gathering. German reconnaissance had functioned correctly. The failure was one of imagination, the inability to conceive of a possibility that had no historical precedent. By June 18, 1944, just 12 days after the initial D-Day landings, both Mulberry Harbors were nearly fully operational. Each was designed to handle 7,000 tons of supplies and approximately 2,500 vehicles per day. The invasion was succeeding beyond even the most optimistic pre-operation estimates. The Atlantic Wall, upon which Germany had spent 13 million cubic meters of concrete and 1.5 million tons of steel over 2 years of construction, had been effectively bypassed. Reich Armaments Minister Albert Speer acknowledged this failure directly after the war. A fortnight after the Normandy landings, this costly effort was brought to nothing because of an idea of simple genius. Then nature intervened in a way that no planning had fully anticipated. Between June 19th and June 22nd, the worst June gale to strike the Normandy coast in 40 years descended on the beaches with full force. Winds reached force 6 to force 8. Waves reached 8 feet in height and struck the exposed harbor structures relentlessly for 3 consecutive days. The American Mulberry at Omaha Beach was destroyed beyond any practical hope of repair. Floating roadway sections broke apart and sank. The entire structure was reduced to debris within 72 hours. Ammunition supplies available to forward units collapsed from 25,000 tons on June 18th to just 4,000 tons by June 20th. General Omar Bradley visited the wreckage and could only stare at what the English Channel had accomplished, where German defenses had failed entirely. The American response to this disaster illustrated a quality that would define the entire logistics campaign: practical adaptability under pressure. Military planners quickly abandoned the destroyed harbor, salvaged every usable component to reinforce the surviving British Mulberry at Arrow-Mash, and immediately shifted to landing supplies directly on the beaches using specialized landing craft. The results were remarkable. Offloading rates at Utah and Omaha beaches after the storm actually surpassed the throughput that the artificial harbor system had achieved at its peak before the gale struck. The surviving British Mulberry continued operating for 10 months, handling over 2 million men, 500,000 vehicles, and 4 million tons of supplies. Simultaneously, the Allies were constructing something that remained completely unknown to German intelligence throughout the entire war: Operation Pluto, which stood for Pipelines Under the Ocean. Conceived in April 1942, The system used flexible pipelines laid across the floor of the English Channel to pump fuel directly from England to distribution points on the French coast. Two main routes were established. Bambi ran approximately 70 miles from the Isle of Wight to Cherbourg. Dumbo stretched approximately 30 miles from Dungeness to Boulogne on the French coast. Pumping stations along the English coast were elaborately disguised. One was concealed inside the ruins of a bombed hotel. Another was disguised as an ice cream parlor, complete with appropriate commercial signage visible from the road. The Bambi system proved technically disappointing, delivering only approximately 3,300 tons of fuel in total before being abandoned. The Dumbo system was far more successful. It eventually expanded to 17 separate pipelines running side by side across the channel floor, reaching a peak delivery rate of 4,500 tons of fuel per day. Total fuel delivered through Pluto reached approximately 180 million imperial gallons, roughly 8% of all petroleum products sent from Britain to support Allied forces in Europe. There is no credible evidence that Germany ever identified or understood this system's existence. The capture of Cherbourg on June 26, 1944, opened another chapter in the logistics story. American forces entering the port found what military engineers described as the most complete, intensive, and thoroughly planned demolition in the history of warfare. Every quay was demolished, every crane was destroyed, every lock was sabotaged. Ships had been deliberately sunk to block harbor channels. The entire port area was extensively mined with delayed action explosives. German commanders calculated that Cherbourg would remain unusable for months. Hitler personally awarded a Knight's Cross to Rear Admiral Walter Hennicke for the thoroughness of the destruction. American engineers demonstrated otherwise. The rehabilitation was led by the 1056th Engineer Group and Navy construction battalions, working around the clock in continuous shifts. The first deep-draft ship offloaded cargo at Cherbourg on July 16, just 20 days after the port's capture. By September, more than 14,000 tons of supplies per day were flowing through the reconstructed facilities. By November, the port approached its designed capacity of 25,000 tons per day. A peacetime facility that had handled less than 800 tons daily was now processing more than 30 times that volume through the same physical infrastructure, operated by American military engineers who had arrived with no prior knowledge of the port's layout. The pattern was consistent across every logistics challenge the Allies encountered in France during the summer and autumn of 1944. German planners designed obstacles, calculated delays, and predicted failures based on their understanding of what was operationally possible. American engineers and administrators systematically exceeded those predictions, not through exceptional individual brilliance, but through organizational capacity, material abundance, and a cultural inclination to treat problems as engineering challenges with solvable parameters. On August 25, 1944, the same day that Paris was liberated, the Red Ball Express began its historic operations across France. The name came directly from railroad terminology, where a red ball painted on freight cars indicated priority cargo receiving expedited handling above all other traffic. This was priority freight transferred entirely to wheels, a massive truck convoy system designed to rush supplies from the Normandy beaches and the newly operational French ports to the rapidly advancing Allied front lines. Nothing quite like it had been attempted before in the history of modern warfare. The challenge confronting Allied logistics planners in late August 1944 was unprecedented in its scale and urgency. Allied armies were advancing across France at a pace that was literally outrunning their own supply lines. General George Patton's Third Army had covered 400 miles from the Normandy hedgerows to the Moselle River in less than a single month. Approximately 600,000 tons of supplies sat stockpiled in Normandy depots waiting to be moved forward. The problem was never the quantity of supplies available in France. The problem was the inability to transport those supplies forward fast enough to sustain armies advancing at a pace that no pre-war planning model had treated as a realistic scenario. The Red Ball Express solved this problem through organizational brute force and human determination applied at a scale that matched the operational emergency. The system used 2 parallel highways reserved exclusively for Red Ball convoy traffic. The northern route carried loaded trucks east toward the front. The southern route returned empty trucks west for reloading. All civilian traffic was strictly prohibited. All non-Red Ball military traffic was forbidden entirely. Routes were clearly marked with large rectangular signs bearing painted red balls on white backgrounds. The slogan read simply, "Red Ball Highway. Stay on the ball. Keep 'em rolling." The operation was conceived during an intense 36-hour planning session led by Colonel Loren Ayers, working alongside Major Gordon Grell at Communications Zone Headquarters. The timeline from concept to execution was days, not weeks. Brigadier General Hubert Planck, tasked with implementation under impossible time pressure, declared as the first trucks rolled, "Let it never be said that a lack of supplies stopped Patton when the Germans couldn't." That statement captured precisely the spirit of what followed, a logistics operation whose ambition matched the tactical achievement it was designed to sustain. Over its 82 days of continuous operation, from August 25th to November 16, 1944, the Red Ball Express delivered 412,193 tons of supplies across France. At its peak, the system employed a fleet of over 5,000 trucks. A total of 23,000 drivers and mechanics kept the operation running around the clock. On its single peak day, August 29, 1944, a total of 5,958 vehicles carried 12,342 tons of cargo within a single 24-hour period. No supply operation in any previous war had moved material at this rate over comparable distances. The primary vehicle was the GM CCCW 2.5-ton truck, known affectionately to American soldiers as the Deuce and a Half, or simply the Jimmy. These rugged, standardized trucks were routinely loaded to carry 5 tons, double their official rated capacity, because the operational need was urgent and the vehicles could sustain the strain. 2 drivers were assigned to each truck, alternating between driving and sleeping in the cab to maintain continuous forward movement. Routes that initially stretched 125 miles eventually extended to 400 miles one way as the front lines moved steadily east toward Germany. The dangers facing Red Ball drivers were not confined to mechanical breakdown and exhaustion. German aircraft strafed truck convoys whenever they could penetrate Allied air cover. Mines were a constant threat along the roads. Piano wire was strung across roads at neck height by German operatives, designed specifically to kill drivers moving at speed. Jeeps traveling with convoys were equipped with angle iron hooks welded to their front bumpers to catch and sever this wire. Windshields were removed near the front lines. Cab floors were sandbagged against mine blasts. At night, all driving was conducted under complete blackout conditions, using only tiny running lights called cat eyes. Approximately 73% of all Red Ball Express drivers were African American, roughly 17,000 of the 23,000 total personnel involved. The United States Army in 1944 was fully segregated by official policy. Military leaders had assigned black troops almost exclusively to service and supply units, based on assumptions about capability that the Red Ball Express contradicted every single day it operated. A 5th Armored Division tank driver described the combat soldier's perspective directly. "If it was not for the Red Ball, we could not have moved at all. They all were black drivers, and they delivered in the heat of combat. We would be in our tanks praying for them to come up with fuel and ammunition." The Red Ball consumed resources at a staggering rate. The trucks themselves burned over 300,000 gallons of gasoline daily simply to operate the convoy system. On extended routes, trucks consumed between 40 and 50% of the fuel they were carrying just to move themselves forward and return. In the first month of operation alone, Red Ball trucks wore out 40,000 tires. Drivers routinely disabled engine governors, pushing trucks well beyond the official 25-mile-per-hour speed limit, destroying vehicles faster but delivering supplies sooner because the front lines could not wait for mechanical consideration. The Red Ball was the most famous of the Allied supply routes, but it was far from the only one. The White Ball Express hauled supplies from Le Havre and Rouen to Paris. The Red Lion Express ran approximately 300 miles from Bayeux to Brussels to support Montgomery's forces. The ABC Express connected Antwerp to Brussels, Liège, and Charleroi, delivering approximately 244,000 tons. The XYZ Express ran 4 separate routes directly into Germany, averaging 13,000 tons daily, and delivering approximately 870,000 tons in total before the war ended. Behind all these truck routes operated another essential system that received far less public attention. The United States Military Railway Service employed approximately 43,500 soldier railroaders by Victory in Europe Day. These men, many of them experienced railroad workers in civilian life, loaded and moved more than 18 million tons of military freight across Western Europe during the entire campaign. They repaired bombed tracks, rebuilt destroyed bridges, and operated captured locomotives using whatever fuel they could obtain. Without the railroads functioning in the rear areas, the Red Ball trucks alone could never have sustained the enormous American armies advancing steadily toward Germany. While American logistics officers were building the most efficient military supply system in history, the German military apparatus was undergoing a quiet, irreversible internal collapse that began not on the battlefield but in the supply depots, fuel yards, and railway stations far behind the front lines. The contrast between the two systems was not merely a difference of scale or efficiency. It was a difference of fundamental structure, one rooted in industrial civilization, the other still dependent on the agricultural past. The most revealing single fact about the German military in the Second World War is one that Nazi propaganda worked systematically to conceal. Approximately 80% of the Wehrmacht's motive power throughout the entire conflict was horse-drawn. The army maintained an average of 1.1 million horses at any given time. Each standard German infantry division required roughly 5,300 horses and 1,200 horse-drawn vehicles simply to move its equipment and supplies. Those animals consumed 53 tons of hay and oats per day, nearly equal to the food requirement of all the human soldiers in the same division. Of 322 German divisions in November 1943, only 52 were armored or fully motorized. The remaining 84% marched on foot with horse-drawn supply trains. Joseph Goebbels, the Nazi propaganda minister, recognized how damaging this reality would appear to audiences conditioned to believe in German technological superiority. He issued a specific directive ordering that only mechanized traffic be filmed for newsreels and cinema propaganda. The carefully constructed image of a fully motorized Wehrmacht, endless columns of tanks and half-tracks rolling forward under the German flag, was a deliberate fabrication. A German soldier recorded the truth in his diary with simple precision. Our route is lined by dead horses that have broken their legs or collapsed through sheer exhaustion. The Wehrmacht maintained an enormous, dedicated infrastructure simply to keep its horses functional as military transport. 236 veterinary companies, 48 veterinary hospitals, and 68 horse transport units existed solely to care for these animals. This was not a marginal or incidental detail. It was a structural characteristic of the German military system that had direct operational consequences every time an infantry division was required to move quickly or sustain operations over extended distances. The contrast with American practice was not one of degree, it was categorical. The contrast in truck production alone was militarily decisive long before the armies met in France. The United States produced approximately 2.4 million military trucks during the war. Germany produced roughly 375,000, a ratio of better than 6 to 1 in American favor. German vehicles, by contrast, came in over 100 different types from multiple manufacturers, creating a maintenance nightmare in which spare parts for one vehicle could not be used in another apparently similar machine. American trucks were standardized around a handful of basic designs with interchangeable components that could be manufactured at industrial scale and repaired by any trained mechanic anywhere in the theater. The fuel disparity was equally devastating to German strategic prospects. American domestic oil production in 1940 stood at approximately 1.5 billion barrels annually. Germany produced about 3.8 million barrels of domestic crude oil in 1938, a ratio of roughly 400 to 1 in American favor. Germany depended on two sources to sustain its military operations: synthetic fuel plants using coal conversion technology and natural petroleum from the Romanian oil fields at Ploiești. Both were finite, both were vulnerable, and both were identified by Allied strategic planners as critical targets well before the Normandy invasion. When Allied heavy bombers began systematically attacking German synthetic fuel production facilities in May 1944, the consequences were immediate and irreversible. German synthetic fuel production collapsed from approximately 92,000 barrels per day in April 1944 to roughly 5,000 barrels per day by September 1944, a reduction of approximately 95% in just 4 months. Soviet forces captured Ploiești on August 23, 1944, eliminating Germany's last major source of natural petroleum entirely. German pilots and tank commanders increasingly found themselves in possession of magnificent machines with no fuel to operate them. The Focke-Wulf fighters sat on airfields. The Tiger tanks sat in their assembly positions. One small but historically revealing detail illustrated the comprehensive nature of American logistics superiority even in basic equipment. The standard military fuel container, known universally as the jerry can, was actually a German invention. The Wehrmacht had designed the elegant 20-liter Einheits canister in 1937, featuring 3 handles for efficient bucket brigade passing, a tool-free opening mechanism, and an interior lining that prevented both rust and fuel contamination. American engineer Paul Pleiss recognized the design's obvious superiority and brought both plans and sample containers out of Germany. The United States military initially ignored his intelligence entirely. American fuel cans were inferior in every practical respect: rolled seams that leaked under field conditions, designs requiring both a funnel and a wrench to open, and no protective inner coating. President Franklin Roosevelt later acknowledged the jerry can's importance directly. Without these cans, it would have been impossible for our armies to cut across France at a lightning pace which exceeded the German blitzkrieg of 1940. By May 1945, over 19 million jerry cans were required in the European theater. In October 1944 alone, 3.5 million cans were reported lost, most to pilferage by soldiers who repurposed them as water containers and field improvisation of every description. Germany had designed the perfect fuel container. It could not produce enough fuel to fill its own invention. Germany's railway network was simultaneously being destroyed from the air with methodical precision. German freight car loadings fell from approximately 900,000 per week in August 1944 to approximately 214,000 per week by March 1945. After that date, disorganization was so complete that no useful statistics were maintained. The United States Strategic Bombing Survey concluded that the attack on transportation was the decisive blow that completely disorganized the German economy. When the railroads failed, Germany had no alternative system to substitute. The Americans could shift seamlessly between rail, truck, pipeline, and coastal shipping as conditions demanded. The Germans were left with horses standing in the snow. Even the most capable logistics system has limits. Those limits became painfully apparent to Allied commanders in the autumn of 1944, when the spectacular advance across France ground to a frustrating halt. Not because German resistance had stiffened, but because the supply lines had been stretched beyond their capacity. The armies had advanced so far, so fast, that the entire logistics architecture built for a different rate of advance could no longer sustain forward momentum. It was the one moment in the Western campaign when German hopes might have been sustained, and the American response would determine the remainder of the war. By August 31, 1944, General Patton's Third Army had run completely dry near the Moselle River, receiving only 32,000 of the 400,000 gallons of fuel required daily for full offensive operations. Patton told Omar Bradley that with 400,000 gallons of fuel, he could be inside Germany within 2 days. For 5 agonizing days in early September 1944, the Third Army, the war's most dynamic offensive force, sat essentially immobile while its commander raged at the situation he could not control. The great strategic debate between Eisenhower's broad front advance and Montgomery's narrow thrust proposal was at its core a logistics argument about how to allocate scarce transport capacity across competing army groups. The capture of Antwerp on September 4, 1944, should have resolved the Allied supply crisis almost immediately. British forces took the massive Belgian port virtually intact, aided critically by Belgian resistance fighters who protected vital dock facilities from German demolition teams at considerable personal risk. Antwerp was the second largest port in Europe, capable of handling supply volumes that would have transformed the Allied logistics situation overnight. But the 55-mile Scheldt estuary leading from the open sea to Antwerp's docks remained firmly in German hands, occupied by forces that had been bypassed rather than destroyed in the rapid Allied advance. Clearing the Scheldt estuary required a brutal month-long campaign through flooded polders and fortified islands that cost 12,873 Allied casualties, including over 6,000 Canadian soldiers killed and wounded. The first Allied supply ships did not dock at Antwerp until November 28, 1944, nearly 3 months after the port itself had been captured. Those 3 months represented a strategic opportunity cost that certainly extended the war's duration in the West by weeks and possibly longer. Hitler responded to the eventual loss of Antwerp with the fury of a commander who understood exactly what the port represented. He ordered a sustained V-weapon bombardment that made Antwerp the most heavily attacked city by rocket weapons in the entire war. Approximately 2,400 V-1 flying bombs and 1,600 V-2 ballistic missiles struck the Antwerp area, more V-2 rockets than London received during the entire war. The Rex Cinema disaster on December 16, 1944, killed 567 people in a single V-2 strike while they watched a film. Despite this terror campaign that continued until March 1945, the port never stopped operating. In the first half of 1945, Antwerp averaged approximately 500,000 tons of supplies per month flowing to Allied forces advancing into Germany. Hitler's primary objective in launching the Ardennes offensive on December 16, 1944, the Battle of the Bulge, was to recapture Antwerp. This objective reveals with absolute clarity that even the German dictator understood by late 1944 that logistics, not battlefield tactics, were determining the war's ultimate outcome. German forces entered the offensive with approximately 5 million gallons of fuel stockpiled, enough for approximately 6 days of full-intensity combat operations, and sufficient to cover only 1/3 to 1/2 of the distance to Antwerp. Hitler's plan literally required capturing massive Allied fuel depots to continue the advance after the initial breakthrough. The gamble failed within the first days of operations. American forces responded with remarkable speed to evacuate their massive fuel storage depots before advancing German spearheads could reach them. Kampfgruppe Peiper, the elite SS armored battle group that formed the main German striking force, captured only approximately 50,000 gallons of fuel at Bühlingen against an operational requirement for millions. Peiper eventually ran completely out of fuel at La Glaise on December 23rd and led 770 survivors on foot through the snow back to German lines, abandoning every tank and armored vehicle his force still possessed. The spearhead of Germany's last major Western offensive had been stopped not by superior American firepower, but by empty fuel tanks. The American logistics response to the Ardennes offensive became what military historians would consistently describe as one of the finest organizational achievements of the entire war. Before the famous December 19th meeting at Verdun, where Patton stunned assembled commanders by declaring he could attack northward with 3 divisions within 48 hours, he had already secretly ordered his staff to prepare 3 separate contingency plans for exactly this scenario. His Third Army performed a 90-degree pivot turn, shifting from facing east toward Germany to attacking north into the German southern flank. The logistics numbers behind this maneuver remained staggering decades later. Third Army staff moved 63,000 tons of supplies in 5 days. They shifted an average of 4,500 tons of ammunition per day to new positions. They distributed 57 tons of new maps covering the changed operational area. They reconnoitered 2,800 miles of road for the reoriented axis of advance. They strung 20,000 miles of communications wire to new headquarters locations and established dozens of new supply depots across terrain that was simultaneously being fought over. The attack launched on December 22nd, precisely as Patton had promised. American forces besieged in Bastogne received aerial resupply beginning December 23rd, when weather finally cleared sufficiently for aircraft to operate. On the first day of aerial delivery alone, 241 transport aircraft dropped approximately 239 tons of desperately needed supplies in just 4 hours. Total aerial delivery over the following days reached over 1,000 tons by parachute and an additional 92 tons by glider, including nearly 8,000 gallons of fuel for the armored vehicles defending the town. On December 26th, tank forces led by Lieutenant Colonel Creighton Abrams broke through the German encirclement to relieve the Bastogne garrison and open a ground supply corridor that ended the siege permanently. Meanwhile, Red Ball Express trucks were racing to evacuate fuel from threatened depots before German forces could capture them. All but 124,000 gallons were successfully moved to safety over 3 frantic days of driving. Those 124,000 gallons that could not be evacuated in time were deliberately ignited near Stavelot, creating a massive, flaming roadblock that physically stopped German armored vehicles attempting to advance westward. The fuel that Germany needed to reach Antwerp was instead burned to prevent that advance. It was a moment of brutal operational logic that illustrated the entire character of the campaign. American material abundance used as both weapon and barrier simultaneously. Omar Bradley captured the fundamental asymmetry between the two military systems in a single precise observation written after the war. Hitler had forgotten that this time he was opposed not by static troops in an imaginary line, but by a vast mechanized American army fully mounted on wheels. That observation was not merely tactical commentary. It described the civilizational difference between two approaches to modern war, a difference that had been visible since the first American truck rolled onto French soil in June 1944, and that the Battle of the Bulge had demonstrated with final, definitive clarity. By the end of March 1945, all 4 American armies fighting in Western Europe had crossed the Rhine River into Germany itself. For Operation Plunder, the main Rhine crossing on the nights of March 23rd and 24th, 432 trains delivered 230,000 tons of supplies to 37 forward railheads in the days preceding the assault. The Ninth Army alone had stockpiled 46,000 long tons of ammunition and 3 million gallons of fuel before the crossing began. At Wesel, American combat engineers constructed a 1,152-foot tactical bridge across the Rhine in just 6 hours and 15 minutes, setting a record for military bridge construction that would stand for years. The German generals who had dismissed American logistics capability now watched these final operations unfold with professional despair. Field Marshal Erwin Rommel had grasped the fundamental truth of what Germany faced. Anyone who has to fight, even with the most modern weapons, against an enemy in complete command of the air, fights like a savage against modern European troops under the same handicaps and with the same chances of success. It was an honest assessment from one of Germany's finest operational commanders, and it described precisely what the Wehrmacht had experienced from Normandy to the Rhine. Field Marshal Albert Kesselring, who served as the last German Supreme Commander in the West, summarized the experience of commanding German forces against American material abundance in a single blunt analogy. Leading German armies in 1945 was like playing a Beethoven sonata on an old, rickety, out-of-tune piano. It was not an admission of personal failure or tactical inadequacy. It was an acknowledgement that the instrument itself had ceased to function, that the supply system underpinning German military power had been destroyed more completely than any battlefield defeat could have accomplished alone. The statistics of American logistics achievement told the story with mathematical precision. American industry provided almost two-thirds of all Allied military equipment produced during the entire war. Nearly 300,000 aircraft, 86,000 tanks, 193,000 artillery pieces, and 2 million Army trucks. The communications zone delivered nearly 48 million tons of supplies to the European continent by Victory in Europe Day. American forces in Europe consumed over 1.66 million gallons of gasoline daily during active offensive operations. Patton's Third Army alone burned through 400,000 gallons per day during the pursuit across France. The roads that carried the Red Ball Express trucks are ordinary civilian highways now, carrying commercial traffic and daily commuters who pass no visible trace of what moved over the same asphalt in the summer and autumn of 1944. The beaches where the Mulberry Harbors once protected Allied shipping are quiet tourist destinations. The pipelines that pumped fuel beneath the English Channel have long since been removed from the sea floor. The rebuilt port of Cherbourg moves commercial cargo without any visible sign of what American engineers accomplished there in 20 days during the summer of 1944. The physical evidence of what the American logistics system achieved in Western Europe has been almost entirely absorbed into the ordinary landscape of modern France, Belgium, and Germany. What remains is the historical record, precise, well-documented, and consistently underappreciated in popular accounts of the Second World War that concentrate on the dramatic moments of combat at the expense of the organizational achievement that made those moments possible. The truck drivers who delivered fuel through mud and darkness and enemy fire across France were not extraordinary individuals in any conventional sense. They were young Americans, most of them in their late teens and early 20s, doing a job that had to be done because the armies at the front could not move without them. The fundamental lesson of American logistics in the Second World War is not primarily a military lesson. It is a lesson about the relationship between a society and the wars it fights. The United States in 1941 was a nation built on continental distances, industrial production, and the practical movement of goods and people at scales that Europeans had not needed to develop in the same way. When that society went to war, it brought those characteristics with it, not as a deliberate strategic choice, but as an expression of what it was. The Germans had trained for decades to produce the finest operational army in the world. The Americans arrived with the finest supply system in the world, built on a civilization that had spent a century solving exactly the problems that modern industrial warfare required solving. When the two systems collided on the battlefields of Western Europe, the result was not a close contest decided by tactical brilliance or individual courage, though both were present in abundance on both sides. It was a structural mismatch, one that Rundstedt had identified clearly by December 1944, and that the record of the campaign confirmed on every road, every beach, and every railway line from Normandy to the Rhine. That is where this story ends, not with a single battle, but with a system and the civilization that built it. Thank you for staying with us through this one. If this kind of history is what you come here for, subscribing to the channel is the best way to make sure you don't miss what comes next. We'll see you in the next video.